Hello everyone, welcome to my final project for Computer Science 3240, Introduction to Computer Systems. Today, I'm going to be showcasing my final project, a fully functional chat room built in the C programming language. This project ties together everything we've learned this semester, from networking to threading, and also demonstrates how to create a client-server communication system that is interactive and scalable. In this video, I'll walk you through the main features of the chat room, the active list, the exit command, the shutdown command, how messages are broadcasted, the role of thread-based concurrency, which is the backbone of the entire system, as well as the files needed for the system to run. Let's go over the key files in my project and their purpose. csap.h. This is a header file that acts as the backbone of the project. It contains shared declarations, constants, and function prototypes used by both the server and client. csap.c. This file contains helper functions that simplify and centralize shared logic. For example, it handles operations like managing the active client list, broadcasting messages, and thread-safe utilities to avoid conflicts between multiple threads. The makefile. The makefile is what automates the build process. It compiles all of the files, links them together, and ensures the server and client programs are created efficiently. It also provides a convenient way to clean up any unnecessary files after building. This is a client-side implementation. It allows users to connect to the server, send messages, and receive messages that are broadcasted in real time. It also handles the disconnection command from individual users by way of the exit command. This is a server side. It manages all clients, coordinates the message broadcasting, and handles commands like exit and shutdown. It is responsible for creating a multi-threaded environment where multiple clients can interact seamlessly. Here we see our first implementation of the active list. Here it is implemented as an array of client structures, with the size of the array being the max user numbers, which is 128. This is our second iteration of seeing the active list. Here, when a new client connects, they are added to the active list in the add client function. In this function, it checks if there is a space in the active clients array. It stores the client socket and username in the next available slot, and it increments the client count by 1. We then see the next implementation of the active list here in the remove client function. This part of the code handles when a client disconnects. It ensures that they are removed from the active list. The process is it iterates through the active clients array to find the client by their socket and decreases the client count to reflect the removal. We then see our next implementation of the active list here in the broadcast message function. The broadcast message function sends a message to all active clients except the sender. We also see the list here in the shutdown server function. The shutdown server function uses the active list to notify and disconnect all clients before terminating the server. It notifies all of the clients using the broadcast message command. It then closes all sockets and resets the client count to 0. Once that is done, it exits the server process. And mutex and v and mutex commands are semaphores that ensure that no threads can modify the active list simultaneously. The exit command is a command that allows clients to leave the chat room voluntarily. When a client sends an exit command, the server removes their details from the active list and sends them a confirmation message. Here's how the server handled it. This line of code checks if the command is /exit. If the /exit command matches, it then prepares this message to be sent. This function sends a message to all other connected clients. This line of code allows the server to exit the message processing loop for the client by using break. The shutdown command is a feature that allows the server to terminate all active client connections and shut itself down. When executed, all clients are notified that the server is shutting down, all client connections are closed, all server resources like threads and sockets are cleaned up, and the server process exit. Let's take a look at the server code. Inside of the work function, the server monitors messages from all clients. If it detects that the shutdown command has been sent, it triggers the shutdown process. The server constantly compares the received messages with shutdown CMD. If they match, it calls shutdown server. The loop then breaks, signaling for the server thread to stop processing further input for this client. The first step in the shutdown server function, a semaphore here, is used to lock the active client array, ensuring that no other threads can modify it while the shutdown process is in progress. Then a message is prepared to notify all clients of the shutdown. The for loop iterates over the active clients array to send the shutdown message for each connected client. After notifying the client, each client socket is then closed using the close function. After closing all connections, client count is reset to 0, clearing the active list. This semaphore is now unlocked, allowing other threads to proceed if needed, though in this case the server is about to terminate and close all connections. This line of code prints a final message to the server indicating that the server has been shut down, and the exit 0 function terminates the server process, stopping all operations. Let's now take a look at broadcasting messages. In the chat room, broadcasting messages ensures that when one client sends a message, it is delivered to all clients that are connected in real time. This function is handled specifically by the broadcast message function in the server.c code. Let me show you how it works. First, this semaphore locks the active list to ensure the thread is safe. This portion of the code formats the messages as to include the username first. If it is a system message, it just prints the complete message. It then uses a for loop to loop through all active clients using the active clients array, and then sends messages to everyone except the sender. Once the message is sent to everyone, the semaphore is released, allowing other threads to access the active list. Let's remember that broadcasting is not just for user messages in the chat room, it is also used for system notifications. The backbone of this program is thread-based concurrency. The chat room uses thread-based concurrency to handle multiple clients at the same time. When a new client connects, the server spawns a new thread specifically for that client. This thread manages all communications with the client while other threads handle the other clients. First, the new thread is created inside of the main function. The thread runs the thread function, which is designed to handle communication with a connected client. The client's connection details are passed as an argument. Each thread manages communication, ensures thread safety, and cleans up resources. This design ensures that the server remains responsive, and scalable, even when multiple clients are connected and actively communicating. Threads allow the server to focus on each client individually. Thread-based concurrency makes the chat room feel smooth and interactive, even as the number of connected clients grow. Now, let's tie everything together with a quick demo.
/server 3240 initializes the server.c file and begins listening for clients on port 3240. /client compiles client code. Localhost is the server IP address and 3240 is the port number. The program then asks the user to enter a username and broadcast the username to all connected clients. This chat room can hold a maximum of 128 clients. Here the username is too long and returns an invalid message error. Blank usernames also return invalid message error and prompts for the user to enter a new username. This is the server terminal, and it shows each user that has been connected and their username. This shows the exit command being used. We can see here that it prints a message to all clients saying Bobby has disconnected and left the chat. Here is the shutdown command. Here it shows that the server has been shut down completely.
There were multiple issues I faced while working on this code. The toughest issue was dealing with thread management of the shutdown command. The shutdown command often caused several issues like invalid thread IDs or improper terminations. Handling the shutdown command also required that all client connections were properly closed, and I also had to ensure that no resources were left hanging out in the open. This was all kind of challenging to coordinate. And then there were more simpler issues that were more easily solved, like message formatting. Small mistakes in message formatting between the client and server caused simple errors or incomplete messages during communication.